All right, welcome, welcome. We are live, and this is going to be an exciting interview. Let me just do a couple of things real quick. All right, so I am joined today with another great guest. First of all, let me say, for those, if this is your first time here, go ahead and hit that like button, subscribe button, hit the bell so you get notified every time we have amazing guests like this coming on the show. And, without further ado, I want to really jump into it because I know your time is precious and there's a lot that at least I want to cover because there's a lot of questions that I'm curious about myself. So let me give a brief introduction. This is Dr. Fazale Rana. He is the Vice President of Research and Apologetics at Reasons to Believe. If you didn't see, a few weeks ago, we had, or actually back in December, we had Dr. Hugh Ross, who founded that organization, on the show. So you are the author of several groundbreaking books that you can tell us about, including Who Was Adam, Creating Life in the Lab, and The Cell's Design, and Humans 2.0, which I think is a really interesting concept that maybe we'll get into. And you hold a PhD in chemistry with the emphasis in biochemistry from Ohio University, correct?
That's right.
So let me just have you kind of elaborate in a second. Before, I want to get into the conversation, like I said, but, I gave the brief introduction, but can you tell us a little bit more about you, about what you do and how you got involved with Reasons to Believe, but also how did you get involved with apologetics, and did science kind of lead you to faith, or did you grow up, in a Christian home, or what was your journey like there?
Yeah. Okay. Sure. Well, as you mentioned, I work for an organization called Reasons to Believe, and the goal of our organization is really to show that there's not only that the Christian faith is scientifically credible, but that there's scientific evidence for God's existence and the reliability of Scripture. And really, our organization exists to kind of counter the message that science and faith are inherently in conflict with each other. And if that conflict does indeed exist, because many people perceive science as objective and as ultimately the pathway to ideas that are ultimately true, that if science and Christianity are in conflict, then it must be science that's true as opposed to Christianity. So that's the objective, overarching objective of our organization. As you mentioned, I'm a biochemist by training, and I have interest in really a number of areas in the science-faith dialogue, but the ones that I focused the most attention on over the 20 or so years that I've been with Reasons to Believe now has been really the origin of life question, the nature of biochemical systems, and then also on the other extreme, the question of humanity's origin. And I'm more recently getting interested into the relationship between Christianity and emerging biotechnologies. And so those are, in a broad sense, the areas that I focus on. So it's questions really relating to origin and the origin and the design of life, and really the origin and the design of humanity. And again, questions about, again, how as a Christian worldview should we interact with, again, emerging technologies that could hold the potential to be incredibly transformative in our world, and ideas that flow out of that, like transhumanism.
So this was not going to be my first question, but now that you brought it up, we just got to touch on that because I don't think a lot of people are even going to understand. I'm not sure I understand when you say transhumanism. Transgender gets thrown around a lot. This is obviously not that. And the Humans 2.0 idea. I heard John Lennox kind of do a lot of talking on artificial intelligence, and just artificial intelligence. We tend to think robots and stuff like that, but there's actually a lot more subtle forms that will probably get bigger in the future. We're starting to talk about self-driving cars and who's liable in those situations. So there's a lot of other factors on top of the underlying factor of, I remember actually I gave a talk for a Reasons to Believe chapter 2 years ago. And the topic of my talk was, what does it mean to be human? And so I think even in Humans 2.0, most people can't define what it is to be human, if you, especially when you remove God from the picture. So can you kind of help us
Yeah.
unpack?
Yeah. Well, the idea of transhumanism really has an origin that goes back to the early 1900s in a book written by J.B.S. Haldane called Daedalus. And Haldane was one of the founders of the discipline of genetics. And Haldane had this grand vision of the future where we would one day have enough of an understanding about genetics and about the process of human reproduction that we could actually create designer human beings by
Mm,
manipulating, each human being's genetic makeup, and then that we could actually even divorce reproduction away from the biological organism to it happening in a laboratory setting, and that we could then really create the human beings that we would need to have certain attributes that fit perfectly within the needs of the society that we find ourselves in. And that idea was the basis for Aldous Huxley's book, Brave New World. And so it's the idea really behind transhumanism is that we will eventually have enough understanding of technology and human biology that we can actually use technology to modify our biological makeup. And in doing so, really overcome our limitations and correct flaws that are endemic in our nature. And in doing so, not only mitigate pain and suffering, but really create kind of a utopian world of our own making.
mm,
And for many people, they even see science and technology as a way to maybe attain practical immortality. And this is where the idea of artificial intelligence and the singularity come into play. Ideas that have been advocated a lot by people like Ray Kurzweil, for example. Um, uh, this idea of transhumanism, again, has been around a long time. It's been largely a marginal idea, but in recent years, it's been propelled really to the mainstream, where because of advances in things like CRISPR gene editing technology, brain-computer interfaces, anti-aging technology, artificial intelligence, these are all advances that are really making this transhumanist vision a real possibility. And again, it's creating a type of faith in science and technology where people are turning to science and technology not only to solve problems, but really as the ultimate source of our salvation.
right.
So it's a concept and an idea that is going to become one of the most important ideas in the next decade or so, really shaping the world that we live in. So Humans 2.0 is, how as a Christian do we think about and engage emerging biotechnologies that can be used for human enhancements? How do we think about transhumanism? How do we engage that idea? Because ultimately, it's really an alternative to the gospel.
Mm. Man, there's a lot to unpack there. We probably have to do a whole show just on that.
Oh
I
yeah,
want
there's a ton to unpack in
to
that.
let me just pull this up real quick because in some ways there are aspects of AI that can be helpful, but like you kind of alluded to, if we take it to its logical conclusion, that's where we get into a phase of now we're being antithetical to the gospel.
Yeah, yeah, and this is really the complexity of it is that all of these technologies can be used for enormous amount of good, and they should be used for enormous amount of good. And as Christians, we want to really encourage that. But yet, they're also they hold the prospects of really uh, doing things in such a way that we can go beyond the point of no return. And it really raises questions about who are we as human beings, really where is our hope, purpose, and destiny lie, and so fascinating questions that are broad reaching.
Yeah. So those are some of the things we're gonna have to we'll have to wrestle with in and outside of the church as we go
Mm.
into these next decades. I remember even as I was leaving the insurance and financial services industry, just when they're starting to talk about self-driving cars, one question that was already being brought up was, well, if there's an accident, who's liable?
Right.
Where does the who pays out to who's ultimately liable? Does someone go to jail if there's like so there's all these ethical dilemmas that if the self-driving car is from Google or Apple, are they are they on the hook, or is it the owner of the car? And so it's just some things we need to think through as
Yep.
people first and foremost. but also especially as believers in Christ.
Yeah, exactly.
All right, so now let me get into my actual questions. And is that book already out, by the way?
Yeah, Humans 2.0 has been out for a little bit over a year now.
Okay.
So people can get it through Amazon if they're interested.
Okay, so yeah, everybody go check that out on Amazon. I need to go get it too. My reading list is ever growing.
Yeah, I feel
um,
your pain.
so here's the crux of I typically, when I'm speaking, especially with in normal times, traveling to speak to different youth all over the country, science is the big bone to pick, because a lot of this, most of the statistics show that 65 to 70% of our young people are walking away from the faith when they get to or through college. And often it's because they have some sort of dilemma with what they deem as scientific evidence, at least in the way it's presented in university setting, because they don't present the full story, right? And so as I learned more, it was kind of like, well, no, this actually validates my faith, because there's some questions that science can't answer. Science can tell you the effect, but it often can't tell you the cause, especially when we're talking about primary cause, primary origin, and those types of things. So the big question, and we won't settle this today, I don't think. I have my own reasons for why I don't think macroevolutionary theory is likely or even possible, to be honest. Can you give us like the 3 high points of why you kind of struggle with that as a viable option?
Yeah, and just let me say that when I was an undergraduate student, I was an agnostic, and I fully embraced the evolutionary paradigm as being, the organizing principle in biology, and really the explanatory framework for understanding biological origins. And really, the grand claim of the evolutionary paradigm is that everything that we see in biology can be explained through evolutionary means. That means the origin and the design of life, the history of life, and even the origin of humanity. And if, for many people, if evolution can account for everything, if we can explain everything we see in biology through mechanism, then the question becomes, well, then what role is there for a creator to play? A creator seems to be completely unnecessary. And that was a mindset that I held to as an undergraduate student. Yet when I became a graduate student, I saw 2 things in my study of biochemical systems. First of all, just the incredible sophistication and elegance of those systems, which suggests design. And then secondly, what I saw to be the inability of evolutionary mechanisms to account for the origin of life, and hence the origin of biochemical systems. And that was about 35 years ago. And over the last 3.5 decades, in my view, the evidence for design in the case against chemical evolution has become stronger and stronger. But the point here is that what that taught me was that maybe, just maybe, evolutionary mechanisms are not sufficient to explain everything in biology. They might be able to explain some features of biology, but not necessarily everything. And after I became a Christian, I held to a view that we would call theistic evolution, or evolutionary creation today. And it was really a number of years later that I began to really see what I saw to be, again, deficiencies in the explanatory power of the evolutionary framework for major transitions in life's history, not only the origin of life, but the origin of eukaryotic cells, the origin of body plans. And so that's one reason, is that I don't think evolution has a grand explanatory power. I don't think there's a mechanism available to evolutionary biologists that can explain things like biological novelty and biological innovation. I think the mechanisms available are great fine-tuning that account for microevolution and speciation, and even maybe evolution at the level of a genus or at a family level. But I question whether evolution can again account for major transitions in life's history.
Yeah.
Also, I see places where the paradigm has failed predictions, and so those would really be the reasons why I'm skeptical.
Yeah, no, and I'm going to add those to my list, because the main reasons or at least I think some of the easier ones for us lay people to understand and grasp is non-transitional forms in the fossil record, or at least the lack of abundance. I would, because if this is a true theory, you would find those forms the most, not the least. So the other part is irreducible complexity. For me, I know we're going to talk about the cell here briefly, but liken it to a car. If you don't have all the parts of the car present at the beginning in working order, you can't evolve to a car because you need it all there at the beginning. So one problem is the gradual theory behind it or embedded in it. If it's gradual, it doesn't happen. I don't see. At least that's how I'm looking at it. And so even when we talk about, well, we'll get to the cell in a second, but the I know people will say, well, over this amount of time, well, then anything can happen. Well, not necessarily. That is I think a very naive position, and I think even probably a lot of scientists in your field aren't that naive. I think it's more or on a common level, lay level, people tend to ascribe to that, but not knowing all the nuances that you just described.
Yeah. Well, I mean, to me, there again, there are, features in the record of nature that don't seem to be fully compatible, with the evolutionary paradigm. So, you're talking about, for example, the nature of the fossil record. Something that I find to be impressive is that every time there's a major transition in the history of life, it always happens explosively without any kind of evidence for intermediary grades. So this, again, is what we see with the origin of life. It's what we see with the origin of what are called eukaryotic cells. This is called the eukaryotic Big Bang. With the origin of body plans, we see things like the Cambrian explosion, where these animal forms with distinct body plans come into existence in a geological instance. Even when we look at our origin as humanity, this idea of human exceptionalism in the image of God seems to appear explosively, when human beings appear on the scene. So those sudden, abrupt transitions, to me, where you're looking at the major events in life's history, are things that you would not expect from an evolutionary perspective, as you're pointing out.
Yeah.
And to me, the idea of irreducible complexity is provocative. But when we go even beyond that, there's so many different features of the cell's chemistry that, like irreducible complexity, I think really raise questions about, can evolutionary mechanisms account for these features, but also they have this eerie resemblance to human designs. That's the thing that's mind-blowing to me, is how similar the designs of biochemical systems are to the types of designs we would produce as human beings.
Yeah. So let's jump into the cell, figuratively. So you have spoken about our fingerprints in our design, right? And like I said, I think irreducible complexity of the cell, but of systems in general, is not just provocative, but I to me it's a defeater, for that type of macroevolutionary argument. But also talked a little bit with James Tour, who, if you guys don't know, is another brilliant. I can't even pronounce his title, nano chemistry something. I don't know, but he does a lot of work on origin of life, and you can find some of the stuff on YouTube. But can you speak about specifically optimization and ingenuity? I remember hearing you talk about those things as parts or functions embedded within the cell, because what I think is important is a lot of times I'll hear, I don't even want to quote Dawkins, but atheistic scientists who they'll talk about everything from here on, but you can't explain this. You can't explain the origin, and
Yeah.
not just can't explain it, especially as I hear you and others and James Tour and others talk about the way the amino acids have to combine. Like, if you take the universe, the likelihood of just making one protein molecule is so ridiculously vast that to assume that life of any kind, let alone complex life such as ours, would come or could come, seems to take a lot more faith than to believe a God did it. What can you tell us about the optimization and ingenuity that you see within smaller self systems and functions that speaks to design?
Yeah. Well, one of the features of systems that are the work of a mind is that they display optimization. And when we look at, biochemical systems, these are incredibly optimized systems, optimized to a degree that is increasingly astounding, I think, to even biochemists. So, for example, the genetic code, which is really the heart of biochemistry, it's a set of rules that actually define the information that you see in proteins and in DNA. That the way that information is ultimately defined is, in effect, the genetic code. And that code is exquisitely optimized for a number of different factors, so much to that it's very difficult to envision how the genetic code that is universal to all life could have ever come into being.
Mm-hmm.
The optimization is extreme. And so people have done a lot of studies where they've compared different features of the genetic code to random codes that they could generate that could have conceivably been chosen by evolution, and none of those codes perform as well as the genetic code in nature when we consider all the different attributes of the code that are optimized. But there are,
and they designed it, right? That's a mind doing it. That's the other part.
right. Well, and there's about, I don't know, 10 to the 80 possible genetic codes that could exist, and the code that we see in nature, again, appears to be unique. But if we just assume that the universe is 10 billion years old, and that there were a trillion organisms for 10 billion years searching code space, trying to find the code that we see in nature, you would take, I think, you'd have to search through 10 to the 38 codes per second in order to find the code in nature. And there's just not enough resources or time available to hit upon the code that we see in nature that appears to be so exquisitely optimized. And so, to me, that is probably the most extreme example. But even like the set of amino acids that are used to build proteins, is again exquisitely optimized compared to any other set of amino acids that could be conceivable. None of them have the properties that we see for the set of amino acids that are used to build proteins. So that optimization is extreme, and biochemists are continually discovering new features of the cell that are optimized to such an extreme that it really suggests a mind.
Suggests it to me too. Seems like a logical conclusion. It's interesting when I was talking with Dr. Ross, and I said, as an apologist and even as Christians, is sometimes we get blamed or accused of reading the science into our theology as though one is prior to the other. And I said, like, first of all, you all came to faith differently, so that can't be true. But also, if I just laid out all the evidence, we can do it in astrophysics, we can do it in chemistry, biology. If you just lay out all the evidence, my natural question is, who did this? Because the way everything is laid out and the specificity with which it's laid out speaks to intentionality. Random chaos is not intentional, nor can it be. And so the likelihood of having an extremely ordered world, let alone systems, let alone organisms, accidentally, far greater than having someone who did this intentionally, especially when that's what it appears to be. Even when we talk about the universe, they were talking about Paul Davies, who's an atheist. He said this is like the hardest thing for him to get over because it seems so finely tuned that it begs the question of a designer. But certain presuppositions get in people's way where they say, even though it looks like a designer, I can't believe in God. But the reason is not because of the evidence anymore. It's something else. There's a moral reason or a volitional reason. And as I talk to a lot of people, especially atheists, I find it's not the evidence. I lay out all the evidence and they agree, and they still don't want to come to faith. So it's something different where there's a heart issue, there's a volitional issue, and that's a different battle.
Yeah, well, and just to build off of that point, I don't think people should dismiss how strong philosophical considerations actually factor into this conversation,
Mm.
because I think, as you're pointing out, nobody or very few people would deny the appearance of design when it comes to the fine-tuning of the universe or even the nature of biochemical systems. I hear origin of life researchers all the time. A lot of times it's tongue-in-cheek, but nevertheless, I hear them say it looks as if the origin of life appears to be a miracle, and yet they are unwilling to uh, follow that evidence to the logical conclusion. In part, it's because of the framework that dictates how modern day science is done, which is methodological naturalism. And the idea behind methodological naturalism is that when you engage in the scientific enterprise, you act as if God does not exist. You don't appeal to the supernatural or agency, but rather you look for mechanistic explanations for everything that we see in the universe. And for most instances, that's okay as an approach to do science. But when it comes to questions of origins and questions that deal with primary causation, as you were mentioning earlier, Alex, that's where, I think methodological naturalism gets in the way, because even if the evidence suggests design, you can't go in that direction. You've got to insist that it's a mechanistic explanation. So you've already excluded one category of explanations from possible consideration for philosophical reasons, not for scientific reasons. And so, because of methodological naturalism, the design that we see in the universe and the living systems must be apparent design. It can't be authentic design.
Mm.
So that has a profound impact on again, this conversation, where people just don't see the design conclusion as being scientific. And if it's not scientific, then obviously it's not objective. Obviously it's not rational. At least that's the way many people think.
Yeah. So let me ask this question, because there's a comment. Someone's asking about kind of like, what are your peers who obviously don't align with you theologically? What do they say when you write the things you write? And, do they see design? Is there pushback from them? What do you see there?
I see very little challenge to the scientific evidence that's presented, particularly with respect to the works that I've done dealing with the origin of life question and biochemical design. Really, where the pushback comes is twofold. One is, yes, we don't have an explanation today, but give us more time and we'll eventually sort this out. Which really is the ad futurus fallacy. You're appealing to future scientific discoveries to solve the problems you have today. But the other one is that hey, we're scientists and this is the arena that we operate in. We're not going to deal with philosophy or theology, so they resist the philosophical or the theological implications by essentially saying, look, we're scientists. This isn't what we talk about, right? And so it's really kind of a twofold response that I see that really indicates to me that, again, as you're pointing out, that the issues ultimately are not scientific in nature, but there are other issues, philosophical, theological, maybe even volitional and moral issues that are influencing how people interpret the data.
Yeah. So, no, I agree with you. I'm just looking at the comment. There's somebody here who I'll just show you so you can see it for yourself. You kind of already addressed it. Is there anything else more that you would want to say?
Well, I think that's actually okay. The statement says I would say that I've never heard a biochemist, molecular biologist, evolutionary biologist, any other person in active research claim they've seen quote unquote design. But I actually, I would counter that by saying that people in the life sciences don't dispute that living systems have the appearance of design. They just simply would argue that design can be explained through natural selection, ultimately through some kind of evolutionary mechanism. So the dispute isn't over really the design that we see, but rather over the nature, or not the nature of the design, but the origin of that design. And again, I think there are philosophical considerations that force people to say that design must be produced by natural selection. Now, biologists and biochemists are always using design language when they describe biochemical systems. They can't get away from that. They utilize teleological language. And so in the 1950s, a philosopher of science, and his name escapes me at the moment, coined a term called teleonomy, which is kind of a companion concept to teleology, where teleology is purpose-oriented, goal-oriented. So when you see design in biology and you're looking at it teleologically, you would say, well, there was a mind behind life that created these designs for a purpose. Teleonomy says, well, there are designs here, but we are going to argue that that design is essentially through natural selection. And so even though we see design, we are attributing it to natural selection, and that then allows us to use design language freely without actually meaning that it really is designed. But the fact is, people can't get away from the appearance of design, from utilizing design language naturally when they describe biological or biochemical systems, and so they coined this concept as a free pass to use design language without essentially embracing the implications of it.
No, that I hadn't heard that term, but that is an interesting workaround. He says arguing about limitations of language isn't an argument for directed design. So actually, that's a perfect segue. Thank you, John, to my next question. So I was speaking, I think at that same event, but I talk about this a lot. So when we think about DNA, let me back up. So within information, just the way information systems are studied or categorized, rather, there's 5 levels of information. There's statistics, syntax. So statistics would be if I sat on my keyboard and just some stuff came up, that's technically information. It's just probably not viable, actionable information. And there's syntax, semantics, pragmatics, and apologetics. And at the level of pragmatics and apologetics, we're talking about information that is demanding a response. It's like we're having a conversation. I'm talking to you, you're understanding, you're giving me back a response. That level of information is the highest level of information. Now, the issue to me for naturalistic theory is DNA is at that level of information. So you're asking me to believe that a random set of unguided forces produce the most complex system of messages ever created. If I use this example, if you're walking on the beach at 6 a.m. and you see written in the sand, there's no one else on the beach, but you see John loves Mary written in the sand, there's a heart with the arrow and all that. Would you naturally assume that a wave washed onto the sand and wrote that? Or would you assume a mind did it, a person did it, without ever seeing a mind? In other words, me looking at what DNA is would make me ask the natural next question: what greater mind wrote this language? Because it's a language. And so with that, can you kind of talk to us about the language of DNA? And also, I think you called it protein grammar, and how the complexity of the genetic language speaks to the complexity of the mind that could produce such a language.
Yeah, well, I really loved your analogy and I use a similar kind of analogy because I think that really helps drive home the point that whenever we interact or see information, we recognize that information comes ultimately from a mind. That is our experience, and that conclusion is yet to be demonstrated otherwise. And so when we see that biochemical systems are in their essence information systems, that again suggests the work of a mind. And to me, it's not just simply that there's information in biochemistry, but that it's also the way that information is structured and organized. You're talking about like semantic and pragmatic information. Well, what makes the information in biochemistry semantic and even pragmatic is essentially the genetic code. That's what's defining that information. And we already talked about the fact that the code is so you've got, again, not only information, but a code, and we know that codes come from minds, and that code is exquisitely optimized. But the way that the information is organized in biochemical systems is identical to language. There's a famous book called Information and the Origin of Life, written by Bernard Ola Coopers, I think is the name of the investigator. He's an agnostic atheist who is an information theorist who looks at molecular biology from that standpoint and concluded that there's a hierarchical structure in biochemical information that corresponds to the hierarchical structure that we see in human language. But beyond that, more recently, people have discovered, as you were mentioning, a biochemical grammar that, again, has qualities that are similar to the grammar used in human language. So that to me is eerie, that it's not only language or information that we see, but it's structured in the way that we would structure information. You know, a lot of times people compare the information systems in the cell to computer languages and to computer systems. And this is, again, a very powerful comparison, because a few years ago, a scientist in Ireland discovered that embedded into DNA is what's known as an even bit parity code, which is a technique used to detect error in data transmission. Or more recently, there are scientists that are now building computers out of DNA. This is called DNA computing, and they literally are using DNA and the enzymes that manipulate DNA to build these computer systems. And what this is indicating is that the metabolic processes in the cell involving DNA, manipulating DNA and replication or transcription, are literally computer operations, so much so that they are, again, inspiring a new area of computing and nanotechnology called DNA computing. Hmm. And so it's these features that, to me, are extremely compelling towards the idea that there's a mind behind everything. It's not just that there's information, but the way that information is structured and handled and manipulated is identical to how we would handle and manipulate information.
Wow. Yeah, it's a thing that I when I kind of learned of this, and we're going to keep going here with this language understanding, because messages that we see, hear, read, or receive in any form or fashion, we always intuitively know that they are the result of a mind. And it seems like this one area where there's the most complex system of messages, some push back on a natural inclination that we have in every area of life. But I think there's other reasons for that. So moving on with the language understanding, can you talk to us about the language of proteins? You kind of hinted at it, but I remember you talking about unigram, bigram, and trigram. In other words, some words, some proteins go together, others don't. Just like you can't just put a bunch of words in a sentence and make a coherent sentence. It has to be the right order, the right types of words. So, also indicating the likelihood of the corresponding pairs finding each other just blindly or repeatedly, for that matter, in nature is kind of the epitome of unlikely to me. But can you help us unpack those terms, unigram, bigram, and trigram, and then just talk about that likelihood?
Yeah, and what you're getting at is a study done a few years ago now by a team of scientists that were, again, trying to understand protein structure. And what they did is they applied essentially information, science approaches to characterizing protein structure, which again is highlighting the fact that you're dealing with information and you're dealing with, a language structure in biochemical systems. The fact that they can apply those techniques to biochemistry and gain fruitful understanding, again, suggests that it's reasonable to think of biochemical systems as information systems and language systems. And people are probably familiar with unigrams, bigrams, and trigrams, whether they realize it or not. Because if you've ever are sending a text message to someone and you start typing a word, down below pop up all these different options where the software is essentially guessing what is the word that you actually are typing. And what's really impressive was when they suggest the next word and the next word and the next word, and many times the software actually gets it right. And what's happening is that people that have developed that software recognize that because of the rules of grammar, when you use a certain word, the likelihood of using another word afterwards is not equal. Certain words are much more likely to be used after that particular word than other words. And so when you are trying to predict the second word or the third word that you're using when you're, again, typing a text message, you're doing essentially what's called an n-gram analysis, where if you're using a single word and you say, what's the probability of the next word being a particular word, that's a unigram analysis. If you're using two words and then what is the probability of a third word showing up, that's bigram. And then trigram would be you're using three words, right? And so these researchers took that concept and they said, okay, in the structure of proteins, there are these areas called domains, which are these independently folded, self-contained units within a protein structure that have certain biochemical properties. And they noted that in proteins, many proteins are built from these domains where the same types of domains recur in different proteins over and over again. And in biochemical systems kind of are a mix and a match of these different domains to create proteins with a wide range of functions. And so they did this n-gram analysis on these domains, and they discovered that certain domains go together, other domains can't go together for whatever reason, probably because of physical chemical constraints. And so they basically, from that, constructed, in effect, a protein grammar that they could then use to predict protein structure, But the whole point here is that, again, they were seeing this this grammatical structure to protein structure, and they, when they compared the protein grammar to the grammar that we see in human languages, they noted this eerie similarity to it. So, in other words, that grammatical system is very similar to the types of grammatical systems that we have constructed as human beings. And to me, that in and of itself is eerie. But if as human beings we are made in God's image, think about this for a minute. Then when we create as human beings who are many creators, when we create, would it not, you not expect, if we are made in God's image, that what we do is unintentionally or subconsciously mimicking what the Creator has already done? And so the fact that we see so many similarities between biochemical designs and human designs, to me, finds explanation in the idea that we are made in God's image, and there's a resonance between the divine mind and the human mind.
Wow. I think, and on a theological level, I think that also speaks to God's desire to have a relationship with us. So there's things that we can discover and then understand Him better, right? And I think that is a bonus gift that we get from people like you and others who do the work that you do. So now we get a window into the magnitude and the majesty of God that we might not have access to just as we live our lives, even understanding the Imago Dei. But like I said, this gives me more awe. This gives me more love, admiration, respect, and desire to know that Creator who could do all these things and the ways in which they were done. It's just, at least to me, it's mind-boggling. So even when scientists, as you kind of referenced before, and even as somebody is in our chat, kind of disputing some things, I'm not going to put everything because there's no point, but let's say it like this. Even when scientists cheat in a lab, and when I say cheat, I mean you are a human. You're using your mind to do the thing. You're trying to reproduce something that you say occurred randomly in nature. Okay, right there, it's a self-refuting hypothesis or proposition to say that this is random because you're trying to reproduce it and you can't even do it with your mind trying to do it, but you want us to believe it happened by accident. So that is what it is. So even when that's happening, they can't create the perfect environment. And so it's not just, like I said, I referenced James Tour, but it's not just the fact that the cell is so intricately designed or irreducibly complex or those things. It's also that you need a certain perfect environment that would produce or could produce the RNA, the DNA, the necessary proteins to produce life. And so in a controlled environment, if you can't make it happen, asking us to believe that a universe characterized by entropy and chaos, that these amino acids could magically find each other first and foremost, and the vast, vast universe, in the precise interlocking formats that they have to, connect in, and do so repeatedly and consistently. So you can't have an accident with a couple of amino acids, because then you got to start over. But nature doesn't know how to start over, because there's no mind behind it, right? That's the whole point. And so, in other words, it's impossible to create the conditions necessary for the first self-replicating protein molecule, organism, or anything of that nature. And I also think that there's a presupposition where we assume, when you assume macroevolution, you're also assuming that things want to become more complex, as though they have a goal in mind. They don't, at least definitely not until they have minds. So I think Michael Behe, I was reading, he was explaining how when we look at the 8 parts of the kingdom, phylum, all the way down to class, order, genus, species, scientists, I believe, of all stripes, I don't think even atheist scientists disagree with this, but you can tell me, that they've never been able to show there's no evidence that any organism can jump past species. So you can't get from genus to a whole new kingdom or phylum. But in order for macroevolutionary theory to be true, that would have to be a viable option, right? Because at some point, there's whales, there's dogs, there's people, there's all these different species. But the genetic and amino acid layout or connections seem to indicate that that's not a possibility. Can you explain from a biochemical point, and we talked briefly about the fossil record, but why is it that you talk about body plans, why are body plans so secure and kind of concrete, where you can't really exit that body plan? At least we don't have any evidence for that happening, or a lot of evidence.
Yeah, well, the explanation can get pretty technical here, but and this insight, at least that I was first exposed to, came from a very important graduate level textbook on the Cambrian explosion, written by Jim Valentine and Doug Irwin, who are 2 of the world's leading evolutionary biologists, who specialize in the origin of body plans and in the Cambrian explosion, which is where in the fossil record we first see the appearance of body plans. And the point that they make is that we are beginning to understand enough about the development process, the embryological development process, to know that very early on in the embryo development is where the stage is set for the particular body plan that the organism displays, right? And so, but we also know that when you begin to mess with the embryological development at the very early stages, that's where things tend to go horrifically wrong, because any mutation or any change in these very early stages of embryological development is going to produce these monstrosities, because you're fundamentally altering the overall design of the organism. But this is exactly where mutations would have to happen to go from one body plan to another, to go from one biological design to another, is at that very early stage of embryological development. Yeah. As embryological development proceeds further and further, now mutational changes are going to have an impact on the organism, but they're going to have a limited impact on the organism, because again, the organ systems are established. They're beginning to integrate with each other later on in embryological development. Well, this is where mutational changes could take place that could drive processes like microevolution and speciation, right? And so the point being that because of the constraints on embryological development that take place, you can't introduce the changes that you need to go from one body plan to the other at the early stages of embryological development. It has to be at the latter stages, but those, again, latter stages are where microevolutionary changes would manifest. So that, to me, is why, in part, I'm highly skeptical that, again, that body plans can evolve from one from another, or that you can have one major group emerging from another major group.
No, that makes perfect sense, and I think as you've kind of highlighted some of the different moments in history. And um, I was reading, and I talk a lot about this. Dr. Robert Jastrow, who he was some kind of director at Wilson Hubble Laboratory before his passing, and in his book, he tells you pretty much in the first chapter, first line, that he's not a deist or theist or anything like that. He's a, I believe, agnostic. But he also says what we find in you know in the what we have evidence for now aligns with the biblical account. So he's saying this, but he's also saying I don't choose to believe that creator did it, although these things line up. So it's not there's not this discrepancy that sometimes gets put out there as fact. And when we really drill down to what are the questions that we can't answer, there are more unanswered questions for me in that macroevolutionary theory. Even I was listening to Richard Dawkins and Neil deGrasse Tyson, and they were asked, what's the one thing you want to know? And even as an astrophysicist, he said, I want to know the origin of life. I want to be able to explain the first self-replicating organism. And the answer is always, we're working on it, right?
Yeah.
Dr. Robert Jastrow also said, scientists who deny this now find that they've scaled the heights of the mountains, and as they reach the pinnacle, they find a band of theologians who have been sitting there for centuries. That even without all the hard evidence, the reality or the conclusion seems to be the same. So I know everybody won't agree, but I think there's good evidence for at least further investigation into these things, because it's not a cookie cutter, cut and dry case as it's sometimes put to us by different, university programs or schools or things of that nature. So let's talk about one more of those issues that I see, at least. And I've spoken about this kind of chicken and egg problem, where when we're talking about the origin of life, so proteins are generated in these cellular factories, I guess, called ribosomes. And ribosomes are also composed of proteins. So in other words, you need proteins composed of DNA in order to produce proteins composed of DNA. And so can you explain that difficulty, but also the similar difficulty with RNA creation or reproduction? And what does RNA do? Because I think a lot of people are more fuzzy on that. And so the chicken and egg issue of DNA and RNA and proteins, that, well, if we're saying this led to this, led to this, led to this, but you can't get this if you don't already have this. So what do we do?
Yeah, well, and I think that this idea of proteins being this chicken and egg system, is, I think a really powerful argument for design.
Yeah.
Because you can't, again, as you're pointing out, you can't get proteins unless you have proteins, and the proteins are playing a lot of roles. They're playing roles in actually transcribing the information from DNA in the form of messenger RNA, which then goes to the ribosome and it's read and used to construct the proteins. The ribosomes themselves are made of proteins. Once a protein is formed, it has to fold, and there are other proteins that are critical for assisting proteins to fold. These are called chaperones. So you've got proteins essentially involved in the production of proteins. And I first heard of this idea from Michael Denton, who is an ID theorist, and he talks about the kind of the auto destruction cycle that would result if you didn't actually have ribosomes that were functioning properly. So in the cell, you've got ribosomes that are working, impeccably to produce proteins. But think about this: if there was a mutation in a protein that was part of the ribosome, then what would happen is it would compromise ribosome function, which means that the next batch of proteins that are produced are going to be more error prone, right? And but that also means the proteins that are going to be used to produce the ribosomes, which means that the next batch of ribosomes is going to be even less effective. And so you wind up in this auto destruction cycle, having mutations in, again, proteins that make up the ribosome. Well, this is a really strong argument for why ribosomes could not have evolved. Because if you had a ribosome that wasn't working optimally, which you would expect in an evolutionary scenario, then the proteins that it's producing are going to be deeply flawed proteins, including again the next generation of ribosome proteins. So you can never bootstrap, the origin of ribosomes from an evolutionary framework, because unless you have impeccably operating a system, you're going to have a system that is essentially incapable of really functioning in a way to sustain life beyond 1 or 2 generations. So this chicken and egg problem is a really serious problem when it comes to the origin of ribosomes and the way ribosomes are operating. But you also have that same chicken and egg problem when it comes to DNA and proteins, because if you don't have DNA, then you don't have the information needed to make proteins, and you can't replicate DNA if proteins don't exist. And so this is called the chicken and egg paradox in original life research. And the way out of it is through what's called the RNA world, where people argue, well, maybe, the very first biochemistry was built around RNA, where RNA was both harboring information and then also functioning as a catalyst. But that particular model is just replete with problems from beginning to end.
And why would the RNA stop doing that if that's what it was doing?
Yeah. Well, well, some people say, well, the intermediary role that RNA plays in today's biochemistry reflects the leftover vestiges of an RNA world. But you can actually show, and this is a kind of a complex discussion, you can actually show that you've got to have RNA intermediaries if you're going to have biochemical systems at all. There's got to be these intermediary molecules to take information in one format and express it in another format, which is DNA and proteins in the cell.
Yeah. No, and it just makes logical sense to me. Sometimes things, we don't have to make them more complicated than it is. Even if people don't know all the specificity of RNA and DNA and proteins. I asked my 9-year-old, and I think probably she was 8 when I did this. I said, which came first, the chicken or the egg? And this is the age-old question. It's like a joke nowadays, right? And she thought about it, and she actually reasoned out. She's like, well, it had to be the chicken, because where'd the egg come from? And then if there was an egg already, who laid the egg? Like, logically, there had to be an organism to produce the lesser form. Even if we think, and this is a question I would always wanted to ask somebody like Dawkins or somebody. I have 2 kids, and anybody that's ever raised a kid, babies are not viable on their own. So whatever was original had to already be in adult form. My question would be then, why would organisms know to start out as adults when that never happens now? It's kind of like a weird philosophical question, I know, but it would have to be an adult form, or Adam and Eve, for example, where there is a potential to create a baby form of your organism's structure. Because if you start out as just this blob of goo, why would that blob of goo know to skip the baby phase, to skip the natural maturation phase, and start at the adult phase when nothing then or since does that? Right? I think, and that seems like such a weird, odd question, but I think it's one that our friend, I don't know if he's still on here, but it's just one that I don't think people have even considered, because their presuppositions preclude them from even thinking that way. I know there's no God, so I'm not even going to consider what the ramifications of that are. And I'm sure you see it more than I do in the world that you're in. But yeah, anything you want to add on that? I mean, I was just kind of thinking off the top of my head.
Yeah, well, I mean, those are the kind of questions that I think are, worth asking, right? Is, and I guess the point is that, intuitively, there are things that we see in evolutionary theory that are really, I think, at times hard to buy. And so I think it's worthwhile in those circumstances to press in on those areas and ask, okay, what really are the explanations? And many times what I see is that the explanations on the surface sound compelling until you begin to strip away some of the surface layers and ask, at a more fundamental level, well, what would it take for something like this to happen? And a lot of times I think the evolutionary explanations are really little more than just so stories that are nice narratives, nice tales, that really substitute for bona fide explanations.
Mm.
And I see this quite a bit. Um, it's one thing to say, hey, this is kind of the grand narrative for how we think the transition happened or life evolved, but it's another thing then to ask the hard question as to, well, mechanistically, what would this entail? And does that the mechanisms what would be required actually exist, or could they reasonably support that kind of transition? And a lot of times when you ask those questions, that's where things, I think, begin to unravel.
Absolutely. My friend just came in. He's making a point. Um, this is another issue, because how do you explain this on a chaos theory, um, or on a random theory, where you, once again, the specificity, the need for things to align just right is embedded in all species that we know of at this point in day. But to assume that um, came gradually kind of it kind of cuts your feet out from under you, right? Because then how do you even get to this level of quantity of organisms, not just humans but all organisms? Because you have to have that at the beginning where they understand how those functions work, right?
Yeah, well, and you know, uh, evolutionary biologists view evolution as a population level phenomena, meaning it's really the populations that evolve, not individual pairs.
Mm,
So you're not going to ever have an individual pair pop up that's going to be a new species, but rather it's an existing species that's a population that begins to morph slowly over time from one population into another one. And if you have populations that separate and isolate according to the ideas, then these two populations will eventually maybe evolve into separate and distinct species.
mm,
But again, the mechanisms that are supporting that kind of gradual transition, are again mechanisms that can explain microevolution and speciation, but can those same mechanisms now account for things like the origin of body plans? And I don't know that
right.
anybody has shown that's the case.
Yeah, not just the origin of body plans, but the origin of life itself.
Right.
At the outset. So, yeah, I mean, I could do this all day. I appreciate you coming on, and I hope everybody that was actively engaged in the discussion maybe learned something, or at least we have something that we can share with other friends of ours that maybe this is a struggle area for them. Maybe you have some people, young people in college that are struggling to wrestle through their faith in Christ and what they seem to be think are contradictions but aren't. And so maybe this discussion can help you help them. I know as I talk to so many youth and young adults all over the country, and even parents, especially. I had one parent, I was speaking at a conference not last year, of course, but the year before. And after the talk, she approached me almost with tears in her eyes and said, my son came home from college and said he doesn't want to be a Christian anymore. And this was the reason. And so I shared what I could, but obviously I couldn't do this quantity. So I just know that this is a real struggle, and it doesn't. And the point is this: it doesn't have to be. There are people like yourself and others at Reasons to Believe, at the Discovery Institute, that have and are working through these issues with the credentials to do so. And we appreciate the work that you're doing. Can you tell us a little bit about what you have coming up next, or anything like that?
Yeah, well, if people want to find out more about what's going on, you can go to reasons.org, and that's our website. That's a great place to get started. And I'm currently working on a book. The working title is called "Fit for a Purpose," and it's
Mm,
about the
my kind of book.
about the idea of extending the anthropic principle that we see in cosmology to biochemistry, and looking at biochemical fine tuning.
So I got one more question. Oh, sorry. So the name of this channel, Relentless Pursuit of Purpose. The other thing I do outside of apologetics, and actually what I was doing before apologetics, is speak a lot about purpose. And I write a blog called Relentless Pursuit of Purpose. I give talks at corporate and in church on purpose, because this is the foundation for what I want to be able to help people arrive at, finding their purpose in life, their specific yet their general purpose as well, which is to know Christ and make him known. The issue is, In a naturalistic framework, you cannot undergird meaning and purpose. And so, once again, I think they're cutting their feet out from under them, because if life is purely random, if we're just dancing to the tune of our DNA, as Dawkins talks about, there is no purpose to life. There is no meaning in life. Now, you can pretend and make up one, but that's not objective. And so, first of all, I'm glad you're doing that book. I need to get it as soon as it comes out, because I think starting at the foundation, you see that not just like there's all these other issues, like we said, the secondary issues that happen. Even if somebody wants to stick to their macroevolutionary theory, okay, that's one thing, and there's issues with that, I think. But you lose so much more. You can't substantiate objectively morality, meaning, purpose, like those other things that I think are the more existential foundational questions of life that people struggle with. You can't even justify asking the question, let alone answering it. And so I'm glad. I appreciate what you're doing with that. I appreciate that.
Thank you.
So let me see if there's any more questions here in the chat. Oh yeah, this is somebody I'm working with. She runs a high school. Yeah, bullied into the traditional, well, we can call it traditional way of thinking. And so show them this. Yes. Let me see if there was any more questions. No. Yeah. Well, thank you, Dr. Rana. I won't hold you any longer, but I appreciate your time. I appreciate everybody in the chat. Make sure you share this with somebody you think it can benefit. And until next time, we shall see you. And just keep understanding that God is in the details. The truth is in the details. And we uncovered some of those details today. Peace.